Hello, I'm Mrs. J, and today we're going to work on the graphing of the rational function, starting with the number 30. And when you're graphing these, the first thing you want to do is find the domain. Domain is found by setting the denominator equal to 0, so x cannot equal 6. This also gets your vertical asymptotes in your open circles. Since this will not reduce, it's a vertical asymptote at x equals 6. The horizontal asymptote is, look at the degree of the top and the bottom. The degree of the top is 0, because it would be x to the 0 power, and the degree on the bottom is 1. When the degree on the bottom is larger, the horizontal asymptote is y equals 0. So we have our vertical and our horizontal. Now we need to find some points. How about an X-intercept? When you have a fraction and you're finding an X-intercept, you set the top equal to 0. If I set my top equal to 0, I have 1 equals 0, which cannot happen. So there's no X-intercepts, which makes sense because if your horizontal asymptote is the x-axis, very rarely, there are special cases where it crosses, but very rarely does it cross. In this case, it does not. The y-intercept, let x equal 0. So we have y equals 1 over 0 minus 6, or a negative 1/6. So that would be the point 0, negative 1/6. So chances are we have to find one more point. If we look at the graph, we have vertical at 6. 1, 2, 3, 4, 5, 6. And then we have a horizontal at 0, so this asymptote, I probably should have, here we'll make it dotted. So our axis is an asymptote. Our point, we have negative 1/6, so about here, which means this is going to approach the dotted line, so it's going to go like this. Which means we need one more point over here. This was 6, because that was at x equals 6, and this is at y equals 0. So plug in 7. So for our extra point, we plug 7 into the original equation. 1 over 7 minus 6 is 1 over 1, or 1. So we go over 7 and up 1, and here's our point right there. And there's our graph. Let's try number 31. So again, find the domain. Domain, 1 minus x equal to 0. Bringing the x over, x cannot equal 1. So that's our domain. If you want interval notation, negative infinity to negative 1, positive 1, and then 1 to infinity. So that would be our domain. Since this does not reduce, it is also gives us our vertical asymptote at x equals 1. Horizontal asymptote, the degree on the top is 1 and the degree on the bottom is 1. When that happens, you take the two leading terms, which means the two with the largest exponents, and you reduce them. The x's cancel, so it's negative 3 over negative 1. Which gives us 3. So our horizontal is y equals positive 3. So we have the vertical, we have the horizontal. X-intercept, To get an x-intercept, you set the top equal to 0. So 1 minus 3x equals 0. 1 equals 3x. X equals 1/3, dividing by 3. So that gives us the point 1/3, 0. For the y-intercept, we let x be 0. So y equals 1 minus 3 times 0 over 1 minus 0, which equals 1. So if we graph it, our vertical's at 1. Put this up some so you can see. Our horizontal was at 3. 1, 2, 3. And then our points, 1/3, 0, which is here. And this is at 1. So we're going to need another point. This one's here. Whoops, I didn't cross very well. And it will approach the dotted line but not cross it. And it looks about like that. The other one is either here or here. Well, we have to plug in a point. This is at 1, so plug in 2. We have 1 minus 3 times 2 over 1 minus 2. 6, so -5 over -1, or 5. So our extra point is 2, 1, 2, 3, 4, 5 here. And then you just draw your line. And there you go. Try another one. 32. F of x equals x over x minus 25. And it's x squared minus 25. So that will factor x minus 5 and x plus 5. First thing we need to find is our domain. The domain is, I'm setting both of these equal to 0. X cannot equal 5 and -5. This will not reduce, so we have two vertical asymptotes. X equals 5 and x equals -5. Find the horizontal asymptote. Horizontal asymptotes, the degree on the top is 1. The degree on the bottom is 2. So the horizontal is y equals 0. Finding the x-intercept, we set the top equal to 0, so we get x equals 0. So the x-intercept is 0, 0. The y-intercept, I'll just put it right by this one. Y-intercept, we let x be 0, and if we plug it in, notice we've already found it. But plugging it in, if you want to double check, is 0 over a -25, which is 0. Probably going to have to find some extra points. If we graph it, so we have vertical at 5 and -5. 1, 2, 3, 4, 5. And -5. 2, 3, 4, 5. And then the horizontal is on the asymptote again. It's y equals 0. Okay, I'm just going to, normally they don't always show this one dotted, but I will mark it so you kind of know or remember that it's dotted. This is 0. 5 and -5. And our point, we had one point right at the origin. This is a case where it crosses. Doesn't cross very often, but notice that this is our horizontal asymptote and we are crossing it. It will never cross a vertical, but occasionally it will cross a horizontal. So we need 1, 2, 3, 4 points. So I'm going to pick a point over here, -6. In between here, -1. On this side, a +1. And over here, a 6. I'm going to plug all of those in. So I need -6, -1, 1, and 6. So you're just plugging them into the original, and I get a negative point, and I'm just going to round it, 5, 5. I get a -0.04. I get, whoops, this one's positive. This one's negative. And +5, 5. So -6 and then a negative almost half tells me the graph's down here. This one, -1, and it's up here. So like here. And then +1, it's down here. So this one is going like this. And the last one, 6 is up at a positive, which means my graph's up here. And there's your graph. $33. Get some more graph paper. I'm going to factor the x squared plus 4 plus x minus 12 will be x plus 4 and x minus 3. It says find the domain, the intercepts, vertical, horizontal, so the same things as before. First thing we find is the domain. Setting the bottom equal to 0. We get x cannot equal a -4 and a +3. So these are either vertical asymptotes or open circles. Notice that these cancel. So because the 4 cancels, the -4 here, the +4 here, that is an open circle. This one doesn't cancel, so it's a vertical asymptote. So it's still a vertical asymptote. We have a vertical asymptote at x equals 3. We have an open circle at -4, and we need to find the y value. Once you reduce it, you can find it. -3/7. So you have an open circle here and a vertical asymptote here. Find the horizontal asymptote. The degree on the top is, well, you can use either one. Here it was 1, here it was 2, which means the top's larger. Same thing here. So if I use the reduced one, the degree on the top is 0, and the degree on the bottom is 1, which means it's y equals 0 again. To find if it crosses, let's see, horizontal X-intercept. To see if it crosses the X and Y axis, our X-intercept, we set the top equal to 0. 3 cannot equal 0. No X-intercept. The Y-intercept, we let x be 0. 3 over 0 minus 3 is 3 over -3, which is a -1. So we have this point, we have our open circle point, and we have our 2 asymptotes. Y equals 0 is the horizontal, x equals 3. There's the other one. And then points. Y-intercept's at -1, so it's here, which means the graph's going here. The other one, open circle, is at -4, -3/7, so it's here. So this is going to go to that open circle. So then we have another one that's here or here. We need to plot a point, something larger than 3. So I'm going to plug in 4. 3 over 4 minus 3 is 3 over 1, or 3. So we go over 4 and up 1, 2, 3 here. And there's our line. That was number 33. One more. Number 34. X squared, oops, oh well, I'll factor it next. But you always want to factor these. So we have x minus 4 and x plus 4 over x. First thing, domain. X cannot equal 0, setting the denominator equal to 0. So that means we have a vertical asymptote, because this will not reduce, at x equals 0. To find the horizontal asymptote, if we look at the degree of the top, it was 2, and the degree of the bottom is 1. When the degree on the top is larger, there's no horizontal asymptote. There is a slant, and so we need to divide it. And we have x squared minus 16. X, to get x squared, I need an x. X times x is x squared. Subtracting, I have a remainder of 16. We don't worry about the remainder. That means that it's going to approach the line x equals y. So if we look at, we need to find x and y-intercepts, but if we look at this, that means if you draw to graph this, the y-intercept is 0 and the slope is 1, up 1 over 1, up 1 over 1. It's just the diagonal. And the vertical is here at 0. Here, we'll make it a little. So you could see it. Now, x and y-intercept. The y-intercept, we just plug in 0 for x. So if we plug in 0, we have 0 squared minus 16 over 0. Notice, can't do that. Can't divide by 0. So there's no y-intercept. X-intercept. X-intercept, you set the top equal to 0. Now you can use the factored form or this one. We have x squared minus 16 equals 0. Bring it over, x squared equals 16. X is plus or minus square root of 16, which is 4. So it's 4, 0, and negative 4, 0. 1, 2, 3, 4 here. And 1, 2, 3, 4 here. So we know our graph goes this way and that way. That's all that's to those.